Somewhere today, something is going to move suddenly in the corner of your vision, and your body is going to react before you actually know what it is. A jerk backward, a sharp intake of breath, your heart rate spiking. All of it happening before your conscious mind has even finished processing what you saw. The real reason why is far stranger than simple reflex, and it reveals something about how your brain secretly works around the clock. You'd assume you see something, recognize it, decide it's dangerous, and then react. That feels like the obvious order of operations. See first, think second, act third. But decades of neuroscience research show your brain frequently runs this sequence almost completely backward, reacting to potential danger well before the seeing and recognizing part has even finished. Start with the basic architecture of how visual information travels through your brain. When light hits your retina, that information doesn't take one single path to your conscious awareness. It splits almost immediately into at least two separate routes. One path travels through the visual cortex, the region responsible for detailed conscious recognition, actually identifying what you're looking at: a shape, a face, a colored object. This route is remarkably fast by any normal standard, but it still takes real processing time, integrating detail, comparing it against memory, building a coherent picture you can consciously recognize. The second path is far more primitive and far faster. Neuroscientist Joseph Ledoux at New York University spent decades mapping this route, which he nicknamed the low road, a direct, shortcut connection running from the thalamus, an early relay station for sensory information, straight to the amygdala, the brain's threat detection center, almost entirely bypassing the slower, detail-oriented visual cortex. This pathway sacrifices detail and accuracy for pure speed. It doesn't need to know exactly what it's looking at. It only needs to make a rough guess about whether the shape, motion, or pattern resembles something dangerous, and if so, trigger a physical response immediately. Think about what that means for the flinch you feel before you consciously register the object moving toward you. Your amygdala has already made a threat assessment and started your body reacting, adrenaline releasing, muscles tensing, before the slower, more accurate part of your brain has even finished figuring out what the object actually was. You're not flinching after recognizing danger, you're flinching while your brain is still deciding whether there's any danger at all. This raises an important question. If the fast pathway is working with such incomplete information, how does it decide what counts as dangerous in the first place? This is where research from psychologist Arne Öhman at Sweden's Karolinska Institute becomes especially revealing. Öhman ran a series of experiments testing how quickly people detected certain shapes hidden among neutral images, specifically comparing modern threats, like guns or electrical outlets, against ancient evolutionary threats, like snakes and spiders. Across many trials, participants consistently spotted the snake and spider shapes faster than the modern dangers, even though guns are statistically a far greater threat to a person living today than either animal. Oman proposed something he called the fear module, a specialized evolutionarily ancient system tuned specifically to detect a narrow set of shapes and movement patterns that posed consistent threats to our ancestors over millions of years. Curved, slithering shapes, quick, multi-legged scuttling motion, sudden looming objects. Crucially, his research found this detection could happen even when the threatening image was flashed too briefly for conscious recognition, using a technique called backward masking, where a second neutral image immediately overwrites the first before it can be consciously perceived. Participants still showed measurable physiological fear responses, sweating, elevated heart rate, to threats they had no conscious awareness of ever seeing. Doesn't that reframe the entire experience of flinching before you know why? Your body isn't overreacting to nothing. It's reacting to something your conscious mind genuinely never got the chance to process. A shape or motion pattern matched against an ancient template. Your amygdala has been running since long before you were born. entirely independent of your own personal experience or memory. Why would evolution build a system willing to react on such incomplete, error prone information? Because the cost of the two possible mistakes is wildly uneven. If your fast pathway triggers a flinch for something that turns out to be harmless, a dangling cord mistaken for a snake shape, the cost is minimal, a brief, slightly embarrassing overreaction. But if your slow, accurate pathway waited for full conscious confirmation before reacting to an actual venomous snake, the delay could be fatal. Evolution consistently favors systems that make fast, occasionally wrong calls over slow, occasionally too late ones, whenever the stakes involve survival. This explains a strange asymmetry you've probably noticed in your own life without naming it. How much more startling an unexpected touch on the back of your neck feels compared to an equally unexpected touch on your open palm, or how a sudden shadow crossing your peripheral vision triggers a stronger jolt than the same shape appearing directly in your central, already attended field of view. Your fast threat detection pathway is disproportionately tuned to unmonitored, vulnerable zones and sudden peripheral movement, precisely the conditions under which an ancestor was historically most likely to be ambushed. There's something worth sitting with in how this plays out in modern life. Far removed from the predators this system evolved to catch: a rope on a hiking trail, a bent stick in tall grass, a coworker suddenly appearing in your peripheral vision. None of these carry any real threat today. And yet, your amygdala, running its ancient, fast, low detail calculations, sometimes can't tell the difference between them and the actual dangers this system was built for. The flinch fires anyway, a tiny physical echo of a survival strategy built for a world that mostly no longer exists, still running quietly, automatically, underneath every conscious thought you have. It's worth noting the fast pathway isn't working entirely alone either. Once the slower, detail-oriented visual cortex finishes its more accurate assessment a fraction of a second later, it sends that corrected information back to the amygdala, effectively telling it to stand down if the initial alarm turns out to be a false one. This is why the flinch typically fades almost as quickly as it arrives, your racing heart and tensed shoulders settling within a second or two once the accurate picture catches up. The system isn't reckless. It's simply front-loaded, willing to react first and confirm afterward rather than the other way around. So the next time you catch yourself flinching at something completely harmless before you've even figured out what it was, don't be embarrassed by it. That reaction isn't a mistake in any meaningful sense. It's a genuinely ancient piece of neural architecture doing exactly the job it was built to do, protecting you first and asking questions later, running its calculations at a speed your conscious mind was never fast enough to keep up with in the first place.